Okay, Doctor.
Okay.
Okay, Doctor.
Okay, Doktor.
Okay, that's good, eh? Okay, welcome back everybody to our class CEG 452 Engineering Survey. So today we are going to chapter number 7 about the advanced survey. The advanced surveying. We not use anymore about the theodolite. We call it anymore apply for leveling. We not go for the conventional method like we are doing a compass, but we call it a large mapping. For example, we're using a satellite, we're using the drone, helicopter, and so on. So we call it a new era in survey. So we call it advanced survey techniques. How we want to know our positions, what is the topography, and everything related to survey. Even though we call it advanced survey, but the conventional survey sometimes offer you better accuracy. That's why we still use theodolite, we still use leveling because the accuracy more reliable and consider it's not really cheap but it's moderate price. Okay, all right. So Nurin come in. Okay, all right, that's good. So you can see I will share with you. We call it the slide. Can you see my screen now?
Yes, Doctor.
Can you see? Yeah, that's very good. Can you see the chapter 7?
Yes, chapter 7.
Yes,
Introduction to
Doktor.
Advanced
That's
Survey
good.
Techniques.
Yeah, that's good. Okay, chapter 7, Introduction to Advanced Survey Techniques. All right, so the lesson outcome. So what is the objective? What is the lesson learning outcome? Means that after this class, what you understand. Number one, this lecture focus on the introduction of modern survey equipment and its application to civil engineering. And after this lecture, the student should be able to, number one, to understand the usage of global positioning system and geographical information system. It's very easy. You have your width. The map is GIS. You know Waze, the application of Waze that you use for, we call it navigations. Sometimes you order Grab. The map in the Grab systems is geographical information system. It have the buildings, name of roads, directions, the color of building, the color of lanes, the color of, we call it, some topography of place. So that is GIS. Where are you on the maps? So they're tracking by global positioning system, GPS, especially you have your mobile. So your mobile data, you have, we call it, internet. Sometimes your handphone want you to on your locations. It means that it will give you, we call it, coordinate. Where are you now? Okay, where is the place you are sitting now? What is next in your front? What is 2 kilometer? We call it behind you. What is 1 meter on your left side? On your right side, 5 meter. What we have? What the obstacles? What is the opportunity, and so on. Okay, so it's very easy when you see the navigations applications. Mean that, so for example, that now using, we call it we call it, you can check, we call it the Grab that you order, and that Grab used by your mother. So your mother and you can know where is the Grab. So you make sure your mother insecure because your mother share the location with you. Okay, because to Grab system or Grab applications, you can make sure your kid, your father or your mother or your friend is a very safe in the service because we can share the live location. For example, that you also can use, we call it Google Maps, and you can share with your friend, where are you now, where are you now, where are you now, and then your friend can check, are you in the trekking, or maybe you are out of the routes to your desired destination. Okay, number two, the understand the usage of hydrographic and photogrammetry survey. You can know the basic principle about how we measure the depth of sea. We're using a laser, we call it sound wave, and how we call it the lake, for example, is not really depths, it's shallow water. How we want to mappings the lake bed, okay? And photogrammetry survey is the old ones where the revelations of we call it air photo during the World Two, where Kodak established a camera, and that camera is bring up by pigeon. You know the birds of pigeon, and then they put the camera on pigeons, and then they put the camera on aeroplane. It is start. We call it the air photogrammetry survey industry during World Two, and is really run by the company named Kodak. Kodax. Okay, all right. Okay, so part one we will cover about GPS. Number two about global. It's not global geographical information system. It's not global. Can you correct the slide? It's a geographical information system. Part one, part two, GPS and GIS. So part two is we want to measure. We call it a seabeds. We want to measure. We call it a riverbed. We want to measure. We call it lake beds. You know, because the underwater you also have lands. You also have the rock formations. How you want to know that rock is the reduced level is higher than point B? So we're using the laser, we're using the radar wave, or we're using a tape for the shallow failure. Shallow water. Okay, and this is call it hydrographic survey, where we measure the underwater topography. Photogrammetry again is we call it where you put your camera, even though your camera is digital, even though your camera is phanchromatics, and then we put it very 90-degree to the gravity, so you can see the objects 90-degree nadir, we call it, from the earth to the gravity line. So normally photogrammetry is moving by the platform. Platform either we call it aeroplanes, either we call it now we call it drones. We take the videos, not even, and then we using the photogrammetry we take the camera put in satellite. That's why we call it remote sensing. Okay, I will also teach you about the remote sensing after this. It's okay, inshallah. Okay, introduction to GPS GIS. What is mean of a global positioning system, GPS? Okay, before you go to the introduction, I would like, so we call it, to give you example. GPS actually is satellite. We have 24 satellite, and then this satellite actually is around from, we call it our land, or we call it from our earth, is around, means that 11,000 kilometer above, and this we call it satellite rotating the earth every day, and then it send a signal to the earth, where on earth we have a GPS receiver. I will show you later on the photo after this. So we go to introduction, and you must remember the keyword. GPS just to know your position. GPS is just to know your position. Where are you now? Where are you yesterday? Where are you last 2 weeks? Where are you last year? Where are you next 5 years? So we're using GPS to mapping you, to mapping the Grab taxi. We are trying to mapping, we call it the lorry driver behavior when they are driving a truck. Okay. GPS is an acronym. Acronym is a very short one. We call it for the global positioning system. It's one of the greatest surveying tools even developed. Actually, a GPS American and they we call it developed it, and they use it for the commercial until their industry of defense. Okay, so actually last time GPS is secrets, like a secret mission for the US. Now they open up for commercial. Okay, it's one of the greatest surveying tools ever developed. Okay, last time Russia also have, we call it the satellite networks. We call it GLONASS. We don't say GPS. They have 8 satellites to locate all the mapping over the world about the positionings. But now I don't know what happened to the GLONASS. Actually, GLONASS have 8 satellites, and something like no story about that now. And is one of, we call it, competitor for GPS for the beginning of the industry. Okay, so Russia also have about the positioning system. We call it GLONASS, GLONASS. With it, point can be quickly and accurately located on Earth by measuring distance to artificial satellite. With it mean that GPS, with GPS, comma, points can be quickly and accurately located on Earth by measuring distance to artificial satellite or to satellite. Okay, right. Okay, so um, what we have now is number one is this is the receiver. So we have a satellite, and this satellite send the signal to the receiver. And this static, we call it static receiver, communicate with this rover GPS. Okay, so this one is communicate with this one. Okay, this one communicate with this one. This one communicate with this one. Okay, this one is rover GPS. This one is static GPS. GPS. Okay, and satellite also can communicate with this satellite, this receiver. So we call it this one handheld GPS. Alright, and through this one satellite, okay, from this satellite also, they can go, we call it, to web server. They we call it, send a signal to the receiver, we call it computer. So they put in web, and from this one they integrate to this one, this navigation. So in Malaysia, very popular, we call it Waze. In UK, very popular, they call it this brand, Tom, in United Kingdom. And from this web also, they can integrate with our handphones. Okay, you look at this handphone, you can see the map, right? You can see the north directions, you can see the streets, you can see, we call it, the green parks, the roads, and so on, everything here. That is, we call it, Geographical Information System, GIS. But if you look at these 2 points, the red one, pinpoint, drop pin, and then we call it the green pins, is related to this satellite GPS based on your web, and then it's going to your handphone. So this is, we call it GPS. So when we integrate GIS and GPS, so you get your integration system in your handphone. For example, Grab. For example, we call it Google Maps. For example, Waze. Okay, and then for example in UK you have TomTom, and more, we call it interesting now because you can see this one is, we call it static map. It means that just one view. It's not static map, we call it 2D map. 2D map. 2D maps. But if you can look at TomTom, it's a 3D map. 3D map. 3D map. Like you see, we call it Google's Maps. Last time is 2D. Now Google Map offer you 3D. So, and then you can explore. So, this is the revelation of the navigation system. From 2D maps, they make it 3D map. Maybe after this is 4D map or whatsoever, because based on the technology. I think you understand this one, You're right. Okay, this one is we call it your static, still remember static GPS, static. And then this one is rover, still remember rover GPS. And they are communicating. And sometimes this also receiver communicate with second GPS receiver. It's also static, but it's something like kinetic GPS. So this one we call it kinetic. Okay, all right. So actually, you must remember that GPS just want to know the location about your static, location about your kinetic, and location about your rover GPS. Okay, and from the rover and kinetics, you can control the boundary. You know, we call it the line of your land. Maybe example that you want to know that the line from station A to station B on your plan, on your side. So you know, by just put it the right positions, and then you bring up the rover GPS or kinetic GPS, and they are communicating with the static GPS, so you can know exactly what is the coordinate X and Y or Z based on GPS satellite. GPS satellite. Okay, all right. Introduction 2. The user will be quite surprised to learn that location of point on the Earth and the distance between those 2 points, whether short or long, can be determined as accurately or more accurately by measuring distance to satellite located thousands of miles out in the space. Wow, thousands of miles, Thousands of miles. Okay. Last time we want to know, we call it point A. This is a line. This one is going point B. So we measure this angle. This angle, right? And then we measure the distance. Right? And measure this distance. So we can know the relative between point A and point B. We know the relative. But GPS is very easy. You put on point A, GPS 1, and then you put rover here. So automatically you know the distance. And then you put static here. And you know this distance, because they give you X, Y, like coordinate in your, like a paper graph. X, Y coordinates. So from these 3 points, you know about the distance and you know about angle, because they're using the coordinate system. So actually, coordinate system, So actually, this is, we call it a very simple survey. We just know about the coordinates, and we can get the measurement of horizontal distance, and we can know the angle here. And GPS also can offer you three coordinates: X, Y, and Z. X and Y is a positioning. X and Y. Meanwhile, for Z is your mean sea level. Your mean sea level, or we call it reduced level. Okay, that's good. Introduction 3. The gravitational pull of the mass of the Earth keep the satellite in orbit. Each satellite tries to fly by the Earth in a straight line at about, this is a speed, 8,650 mph. M is mile, P is per, H is hour. That is speed, or 30,918 km per hour. But the gravitational force of the Earth pull it down. Okay. As the result, the satellite falls vertically in a path that parallel to the Earth's curvature. So satellite always fall vertically in a path that parallel to the Earth's curvature. Okay, if the satellite velocity will decrease, it will fall to the Earth. Okay. So the satellite is moving. How about you are going slow down the speed from 8650, for example, that you go just for, we call it 8,000 miles per hour. What happened? The satellite is going down. Okay, there's example 1. Decrease. If decrease, this one. If increase, it will be leave the Earth and move further out into space. That's why this one is, we call it the physics. They calculate about the physics theory. They can get the speed of GPS. Alright? You cannot decrease, you cannot increase the speed of the satellite, especially GPS satellite. The GPS satellite are approximately 12,600 miles or 20,278 kilometers above the Earth's surface, with their orbit are completely free of the Earth's atmosphere. Mean that at this height, we cannot decrease or increases. Okay? Less or more than this speed, to make sure we call it satellite, is steady on space, and it will transmit the radio frequency to the Earth to make sure the people know the locations of points, the location of the people, the location of roads, the area, the boundary, the volumes, what they want to measure or what they want to know. Okay? So this is a satellite GPS, and this one is a solar panel. And this solar panel creating electricity energy, because on satellite normally here we have a camera. It's operated by electricity, camera. And this camera going down to us. Okay, straight away going down to us. And it capture, we call it the, it's not the capture, it gives you, we call it, it will transmit the wave. And that wave received by static GPS. Or still remember that, rover GPS or kinetic GPS. Alright, and it always transmit the radio. They don't have camera, sorry. They have, we call it here, it's not camera, we call it transmitter, sorry. If camera is, we call it another satellite. This one is under GPS. This one is GPS, so transmitter. This transmitter will be always produce a radio wave, and this radio wave touching the Earth's surface, and if you have the device, can read the signals, or we call it the wavelength of the GPS satellite, so you can get the coordinates. Okay, so this is, we call it GPS satellite. Okay, now we are going to, we call it this. Okay, you can see this one, satellite moving based on 6 paths. 6 paths, Satellite is moving based on 6 paths. Okay, if you understand like this, it is, we call it sorry for these interruptions. I will try to sketch. It is your Earth, and then six we call it all like this. The satellite rotating this one, and it's going to this one, it's going to this one 3, it's going to this one 4, it's going to this one 6, and it's going to 5 and 6. So like this, they have the path like this. Okay, so one path until it will connected like this. So that it travel a globe, and they have 6 paths. So I think I should erase this one. So they have actually, we call it 6 paths. And every path at one path, okay, 6 satellite navigated. 6 satellite navigating. All right. So if you have 6 paths, okay. So sorry, this one is a 4 satellite. This one is a 4. This one is 4 satellite. We have 4 satellite for the one path. Okay, you know that this is example of one path. The satellite will going down and up back at the back of the Earth. So we call it one path. Okay, so actually satellite have 6 paths. So every one path you have 4 satellite. So if you have 6 paths, mean that you have 24 satellite rotating in 6 paths, 24 hours per 7 weeks per 365 days for the whole year. So satellite never sleep. But if you are going to read the article, sometimes they call it GPS, have 27 numbers of satellite. Okay, but I told you 24. Now they claim 27. Which one is right? 24 or 27? The right answer is 27. Why? 24 is confirmed, plus with 3 satellite in standby mode. Mean that if you have another satellite, it's not really work, so they replace the positioning with 3 satellite that they standby if anything happen to the existing 24 satellite. Okay, and this satellite moving is controlled by the ground station. One of them at the Hawaii Islands at United States of America. So all the satellite is navigated by the ground control stations. One of them at Hawaii, United States of America. Go. Now we go to next. GPS receiver. All right. We go for the GPS receiver. I think you still remember that's this one. This one. I told you about this one. If we have 3 receiver, static. We have static receivers. Remember that? Static receiver. This one is rover. This one kinematic. This one is main. Main that satellite will send the positions. Okay, to the static, and then the static transfer to kinematics and rover GPS. So this one we call it kinematic, statics, or rover is the receiver. This one, slide number 14. GPS receiver. Handheld receiver, you still remember that handheld receiver? Can you remember the photo? This is handheld GPS, handheld GPS receiver. Okay, this one, all right. We're coming back GPS receiver. So GPS receiver used for spotting and outdoor activity. For example, what? Fishing. You're going to fishing, you want to know where are you on the sea, because the sea we cannot see, we call it the signboard. We don't have, we call it a road. We just navigate by GPS. And normally we call it the people who's very expert on we call it on fishing. When they are fishing, they can get a catch. For example, the big fish, or they can get a big squid. What they are doing? So they logs the GPS coordinate at that point, and the logs the position where they can mine the goods. They can catch a good fish, a big fish, is very high quality and type of fish they want. For example, that's they have a big squid, they get it from Terengganu. So they save the location. So next year, at the same place, at the same times, they're going again to the sea. They open up the safe data about the locations on the sea, at the sea, where they can catch a big fish or the big squids, and very delicious and tasty when cooked. So they go to the locations by boats, but they open up the safe locations from the last year data. That is good about the GPS, one of that. Okay. From GPS also they locate about the big fish. Actually, on that area they has a big phytoplankton, because the phytoplankton is one of the main foods for the fish. If you have a very huge phytoplanktons, the fish, or we call it the seafoods at that place, is very tasty, big, and you can get a huge size. So there is the, we call it the people who love fishing as a recreation activity or sports. They are very crazy about using GPS. And normally, I don't know, but they recommend about the brand of Gemini, the brand of Gemini. So handheld receiver used for spotting and outdoor activity. For example, outdoor, when you are using GPS to tracking Gunung Kinabalu. When using, we call it GPS receiver when you have 4WD car in the earth, or we call it you are cycling on the ground based on competition. You are cycling on the ground where the ground surrounded by the forest. You don't know where you should go. What is the next for the 5 meter? So using the GPS. And now army, the whole world, when we call it infantry division. Infantry means that the army walks to do the operations. Even though on deserts, even though we call it GPS, they use the undersea, and then sometimes for training, and sometimes for, we call it the standby. So they're using GPS to move their teams and to do some strategy to make sure the army team always win the war, right? And the accuracy is 5 meter with good exception. If you have GPS handheld, so the accuracy 5 meter is very good. And then its accuracy is up to 1,000 meters under adverse condition, and cost from 200 USD and to 1,000 USD. If the Malaysian money is from ringgit Malaysia 678 ringgits to 3,388 ringgit Malaysia. And this, we call it gadget or technology, especially for GPS, become cheaper because many competitors and many people know how to do the GPS. And you must remember that we are talking about GPS receiver, right? Because of the accuracy of this GPS receiver is 5 meters around. That means like this. If you have this point, so your position may be around 5 meter radius. It's not this position. Maybe a position like this, maybe a position like this, maybe a position like, you are not doing the accurate. Until to 1,000 meter, 1,000 meter, around 3 to 4,000 feet. Mean that if you have this circle, this one is, we call it around, so the radius is 1,000. So diameter is 2,000. Mean that your position you don't know. Around this one, we don't know which one is the right one. It means that GPS receiver you cannot take it to measure, we call it engineering survey. We cannot do engineering survey because unacceptable. The accuracy is too high, 5 meter to 1,000 meter. So what we should control this one? One, we're using, still remember that, rover, statics, and kinematic GPS receiver. We not measure by using GPS receiver for the project, especially we call it for the land boundary, because it we contribute a large error or unacceptable error that will bring your company to the court. Because you encroach 5 meter means that if you encroach 5 meters, it means that 15 foot you're building on the adjacent land. Mean that your building site 5 meter or 15 foot is on the neighbor grounds. So your neighbor will be angry after they are doing a survey. So you must pay them the compositions. If they don't, we call it give permissions for you to acquire the lands. Okay, geodetic receiver used for surveying have the capacity to calculate position using the data from two receiver. Okay, one of another GPR receiver is a geodetic receiver. Used for surveying have the capacity to calculate position using the data from two receiver. The cost is 5,000 to 80,000. Why we call it using to calculate using the data from two receiver? It means that they try to improve the accuracy. Example, this one 5 meter, maybe they're going to up to 5 meter. But still again, GPS receiver, we cannot do the engineering survey. That is the keyword over there. Okay. GPS receiver. Geodetic receiver use one of the base station and acquisitions time of 30 seconds. Will yield accuracy 5 mm plus 2 mm per kilometer of distance below them, between them. Sorry. There is an accuracy of 25 mm for a kilometer radio circle, and most GPS receivers are now multi-channel and can receive the signals from 8 to 12 satellites simultaneously. This one, yes, we can use for, we call it our survey works, because it will improve the accuracy. So the accuracy is very good. What they tell to you, this one, all this story, is just to improve the accuracy, right? So this is a geodetic receiver. Geodetic receiver. So still remember that this one is static. So we have the antenna here. Antenna. Antenna is, we call it to strengthen, to receive the signal from GPS satellite. It's from satellite. So this one is satellite. And then this one you have two. One is we call it kinematics. Second, we call it satellite receiver. So this one is static. All right. So for 1 point, to make sure that your satellite receive 3 satellite simultaneously, meaning like this. If you have satellite number 1, this is your satellite number 1, satellite number 2, and satellite number 3. So your static GPS receives signal from satellite number 1, number 2, number 3. If you have 3 satellite, you receive 3 satellite signals or the radio signals at one time simultaneously. So it means that the coordinate you get here from your data logging is a very high quality. If you get more than 3, 4, 5, so the accuracy is better. The accuracy is better. But 3 is enough. But if your static GPS just receive 2 satellite, 1 and 2, this is may not count in our engineering survey. Engineering survey, we accept only if the signals of radio from 3 satellite at least we call it minimum. But when your surveyor, when we call it you're working, you have your surveyor, you have your workers, they give you a data, the GPS receiver just show 2 reading or from 2 satellite. At one time simultaneously, you must reject the data. At least 3, you must remember as an engineer. So this is the analogy. You must have 3. 1, 2, 3 satellite. That is to determine the positioning. Okay? All right. All right. The principles. You still remember that? Actually, it's not 21, it's 24. This one, it should be 24 satellite. This one should be 24 satellite. 24 satellite move in orbit and their position are continuously monitored and predicted. So monitor mean that they and predicted is based on people who working on the ground receiving station. Ground ground control station. Sorry, ground control station. Ground control stations. So one of them in Hawaii, in the island of Hawaii. And orbit information is updated every 8 hours. So the orbiting informations, information is updated every 8 hours. Okay. And the GPS receiver on Earth has a clock that measure the time taken for the broadcast signal to reach it. So GPS receiver on Earth, especially you remember that this, we call it a receiver. We have also the clock here. The clock is logging the data. Times, X coordinate, Y coordinate, and Z coordinate, and time. And moreover, we have date. So you have X, Y, Z, you have clock time, and maybe you have your notes about your date of doing survey. So this 5 data is completely, absolutely is the very good points to show where are you, what is the area, what is the length, how we want to calculate we call it the volume for this cut and fill. So we just use GPS perhaps or it's by 24 satellite with 3 satellite on standby mode. Okay, then we go here, positioning methods. There are 3 different methods. Okay. I think I already told you about statics, rapid statics. What is kinematic? This one is more detailed. Static. 2 units receiving data from the same satellite for a period of up to 30 minutes. Better accuracy but slow. So when using the static, we have 2 units receiving data from the same satellite for the period of up to 30 minutes. So we are set up, we call it a tripod, we call it GPS antenna, and then you on, and then you wait at the same point A, point B, simultaneously you have, we call it tripod with your GPS antenna, and then for 30 minutes you reach the positions value X, Y, Z, and then plus with clock time, plus with a date. So you go to process, you know that you clean up the data or you do some correction at, we call it receiving static GPS on point A, and then you also have a data on the static point on the station B. You receive the data from the satellite, at least 3 satellites at each point. All right. So you do you go to the software, you download, and then you do the corrections. And after you do the correction, you know exactly what is the coordinate on point A, and you know exactly what is the coordinate position on point B. Based on this position, you know the distance and the angle. Alright? So rapid static is a more sophisticated processing technique, very high accuracy, which time taken is as fast as 30 seconds. This one 30 minutes. This one is 30 seconds. So that's why in GPS, you can set one mode from static, you can set to rapid static, or the device already have, we call it specification about rapid statics. So you save your times because you just, we call it a measure just only 30 seconds, and then you can get the data, and then you can process and you can do the corrections. But if you compare static and rapid statics, the data accurate more on static. Okay, kinematic, one receiver only, which continuously moving, lock on the satellite must be maintained. That like this, you know the GPS backpack. In that, you bring up your GPS on back of you, and then they have antenna and they have poles. Put in your, we call it bags, and in your bag you have a GPS receiver, and then you are, we call it, walking along the river. So when you go along the river is not straight up, it's going to left, curve, going to right, curve to right, curve to left, and so on. You follow. So you can get the shape of the river after you finish, and then you get the all coordinates, and sometimes you know the width of the river, and the length of river, and the shape of river. Okay, that is, we call it kinematic. Normally we use for the mapping the linear things, or the linear, we call it objects on earth, normally nature. For example, is a river, you want to measure, to do, we call it contour rings. You want to know the area of surface of lake and so on. So using the kinematics, it's very good for mapping. So next we have what we have here is application application of GPS. Okay, geodetic position control. Okay, geo mean joy mean earth. That mean geo mean your earth. Okay, position, you know position, the position, everybody like people's, probably the position is the moving at some time, at every second or every minute or every hour or every day or every year. Okay, but position for the thing is static. For example, the roads, there is maintain the road, so the changes is about the width and the length. Okay, so there is position. So control means that we are not control everything, but we are doing GPS survey based on SOP or procedure. That's why we call it control position genetics. Okay, genetic position control. So number one is minor station positioning, control point for further survey works, ground control for the photogrammetry. Okay, sometimes you are involved with the photogrammetry peoples. So they are, we call it, take the camera, put in, we call it the aeroplane bots, and then they fly. So when they fly, they need one ground control points that can be appear clearly on their image during they are flying, because they want to know that points, the X, Y, and Z. If they know that points through the photogrammetry fundamental knowledge, you can calculate everything about the tree heights, about the contourings, but they just want to know the first point. What is the position? So normally they build up triangulations, a shape in triangles like pyramids. Okay, the pyramid normally they have three surface, but this three surface is, we call it flat. This one no, it's something like wing, something like, you know, arrow. And then they have when you see on the top, based on the photogrammetry or based on from the aeroplane view, they can see, we call it, this one is something like a pyramids. So the top or the center one is, they want to know what is the XYZ. So you put that things on one positions that you mark on grounds. Before you put that marker in a, like the arrow positions, or triangle positions, you put GPS static and read the reading at least 30 minutes about X, Y, and Z. And then you record X, Y, Z, the data about your clock times, about the coordinates, and the dates. Okay? So, after finish, when they want to fly about the photogrammetry, you bring up this tripod triangulation on the position where you are taking the coordinate during GPS. So that is how we call it. It's a very drastic. We are helping the photogrammetry by GPS techniques to know X, Y, and Z. Okay, next. Locating infrastructure for geographical information system. That is very good. What, for example? So, for example, that you still remember this one is kinematic survey. So, you know that Google, they have a maps. So, what they do is very easy. Last time they're using, we call it satellite, to acquire the maps. Now, what they are doing is they have a car. On that car, on the shield, on we call it the rooftops, they put, we call it I think more than 3 cameras, and they put also the kinematics GPS. All right, and this kinematic give them the road shape. For example, like this. For example, like this. For example, like this. And this one is a maps. So this is, we call it route number 16, this one route 15, this one route number 13, this one is number 14, this one is main road, for example, highway, federal highway. So this map is a GIS. So the kinematics GPS survey can give you geographical information system, GIS, or very easy, we call it a maps. A map, maybe now they have 2D map or 3D maps. Okay. All right, last one, data survey. This is subject to development. GPS cannot be used successfully in all situations. Example, forest and city. Data survey, for example, like this. You have this map. Where is the position of the lamppost? Lampu jalan, lamppost. So, you take GPS, all right? For example, lamppost here. So, you take GPS, attach to the lamppost and get the coordinate. And then you mark on the map, the coordinate. You have a lamppost, for example, and maybe you have, we call it a bus stop here. Maybe you want to mapping that, so we call it, here we have a barrier, or we call it end road here, lost road, and so on. So everything you are mapping. For example, for the single things, lamppost, maybe you want to add on something like the river cross here. All right. Maybe you want to know about the signboard locations. Maybe you want to put one dot about the bus stop or the bus station or the grab points. Maybe you want to put here just one point. You say that KLCC. Maybe you want to put here, we call it Bank Rakyat and so on. So you take the GPS coordinates to make sure they can successfully to do a detailed survey. Okay, and then maybe a tree landscape, right? We want to put in a map. So we're using the basic GPS where we put a GPS at the tree so we can get the coordinate. We put in the system, for example, 1000, 1002, about the position about the tree for representing of the landscape on the Kuala Lumpur of Malaysia. And GPS also had a problem, even though it's at crowded area at something like at KL, Bukit Bintang area, KCC area. So because the satellite cannot receive to your satellite receiver. Why? Because the building blocks the signal. Right? The building blocks the signal. And for example, forest. When you go to the Grade 1 forest, for example, in Sabah, Sarawak, they have still logging. They have logging is pembalakan. So the tree have a very huge coverage. So GPS satellite, they transmit the signal and they cannot penetrate until the grounds of the log tree because the leaf will reflect back or bounce back the signal from satellite. So when you go to forest, when you go to, we call it a very congested city, so GPS signal is not something like easy, less accuracy. You want 3 satellite, actually you have just 1 satellite, and this become the GPS problems. So if your sky is narrow or your sky is have a huge coverage, the GPS signal from GPS satellite, 24 satellite, cannot be reached, cannot reach your GPS receiver. Either you are doing static, you are doing a rapid static, or you're doing the kinematic method. Okay? And GPS also, they are using for the offshore positioning, ship and plane navigation. Of course, when you go to the commercial aeroplanes, I still remember that I have the one opportunity to see, we call it the pilot board aeroplane, the pilot rooms, meaning that the navigation control. So I'm very surprised because the navigation system they're using GPS and GIS. Okay, and they also by that they're helping with the radar, by helping with the another measurements because the aeroplane is run very fast, so they need, we call it all the data. And you know the offshore positioning and ship. You have the platforms of oil, for example, that we have Petroleum National, like Petronas. When they do a Cari Gali, or we call it oil explorations, and then they come up with a crude oil. So the outcome is the crude oil. So the crude oil, they must put on the ship. So this ship is very big, and this ship must encroach at certain area beside the platform. So because the ship is very huge, it's very big, it's a very, we call it hard to control because they're using the propeller system for the ship. So to make sure the ship is parked based on desired parking on the sea, right? So they need GPS, they put alongside of the platform and alongside with the, we call it the ships, and they make sure the coordinate both is nearby, it's very near. Then they will stop, navigate the ships to parking at offshore. So they're using GPS to make sure the ship is correctly parked at the parking provided by offshore platform, because after that they will we call it load the ship, and then they will fill up the tank in the ship for the crude oil. And the ship must be always in navigation, and they always see the positioning by GPS to make sure the ship is not moving during the filling of crude oil. And if the ship is moving, mean that the crude oil or the pipe will be burst. So this become more dangerous because the crude oil normally plus with gas can cause the explosions. So they're using the GPS to make sure that offshore positioning ship navigation is on the right place on the right time. Number 2, position and tilt of area survey camera at the instant of exposure. For example, there's the camera, maybe on the drone, maybe last time in the photogrammetry on the, we call it aeroplane, and that camera you can tilt. Number 1 is 0, we call it nadir. You can get 2D object, and if you want 3D, you rotate around 30 degree to 45 degree your camera, either your left, right, or in front, or going to backs. So when you do this, you can get 3D elevations. So sometimes the survey, not important point, yes, we go for 2D because we cannot, we call it, we don't tilt the camera. Either we call it going to front, going to back, left or right. But some of the part, for example, that we want to see the height of tree or the log, or we call the height of a kayu balak tree, okay, cengal tree, what is the height? So you can tilt the camera to get, we call it direction of the tree trunk. So from that, you know that which positions you want to tilt your camera, because you want to know the height of the trunk, okay, and one you don't, and where is you want to off your camera and normal back to 2D. So the GPS can give you the value where you want to tilt up, tilt down, or make sure your camera is not tilting. So you monitor the GPS that bring back together with the aeroplane. Motor car navigation system now is, you know that, very crazy, we call it AI system, artificial intelligence. The car can parking by themselves, the car can parking by herself and so on by itself. So they're using the GPS and artificial intelligence system. So they also need GPS, because GPS can give you the parking area, the parking coordinate. Road fleet monitoring and control. Sometimes this one is, the roads, we have maintenance works, sometimes settlement, sometimes you have road accident where your furniture of road is going out and so on. Then what you can do is, you using GPS, you control your, we call it maintenance works, okay? You can control your maintenance works. And you can control and monitor. Sometimes you can see that this area, they have another problem. For example, that you can see that always that place, when you go by using GPS, you measure the height is 5 meter. Next 2 months, you measure by using GPS, going to 4 meter, going down settlement. And then next 5 months, you have also complaint, you go and using GPS, you can see that the settlement going to 3 meter. So you don't know, you suspect that is, we call it, that is clay, and you don't know that. And then what you do is, you put, we call it, the aggregate or the rocks, 20 mm and above, we call it order that once from your supplier, and then you dump it and make it flats, and then you do the road finishings after you compact. After 1 year, you can see that the road still doing, the stood is, we call the road still occurs about the problem of settlements. And you measure with GPS, the first day you have a complaint, you go is maybe 2 mm, then next 2 months they're going to 1 meter and so on. So you're unsatisfied. What are you doing now? Because maybe we already tendered out 100 over thousands, but the problem appear again after 1 year. Then you go and start monitoring. You can see that this is not based on the soil type. Actually, you can see that the side of your road is, we call it the slope, where the slope bring up the water down. So you must divert the water before you are doing the repairing work of settlements. So GPS can give you a road fleet monitoring and control, especially in maintenance. Okay, right. Handheld unit for bush navigation, search and rescue. Sometimes we call it a fire and rescue, the police and so on. They're using, we call it handhelds to navigate. Navigation means that they have the maps, they have the coordinates, how they want to navigate from the first points going to the coordinate they want to rescue the people or to rescue the animals. They want to search the helicopter who is missing. They want to rescue the peoples. They want to take the people who we call it have injured after they're hiking a mountain for the 20 days. So they are doing a navigation by using the handheld unit of GPS. Okay, next. You know that GIS, Geographical Information System, and if you want to easy, how to make maps. How to make maps, one of that is using photogrammetry. Last time we are using land survey. We call it a compass, still remember that? We're using a labeling, okay, and then we're using we call it total stations, okay, this one terrorlight, this one compass, and nowadays to make it maps, okay, based on these topics, so maps, we are producing by the air photo or photogrammetry, or we're using we call it satellites, all right, and sometimes now they have drones, okay. It's a very cheap one. We're using a satellite for the large mapping, all right. Maybe you can see we call it Google Maps. So Google Map using a satellite. If I'm not mistaken, they're using the satellite of Landsat. You can Google search this one, Landsat. So Landsat is have the whole capabilities. For example, that Landsat is not GPS satellite. GPS we have 27. Landsat just one satellite only, one satellite. And for example, that today the Landsat via Malaysia is a pass through Malaysia. This we call it today. After 14 days, like COVID, after 14 days, the satellite orbiting back Malaysia. Like COVID, after 14 days, you know the results, either you're positive or negative, or what happened. Okay. Same with the Landsat, after 14 days, today is, we call it the Landsat satellite visit Malaysia. Next 14 days, he revisit again Malaysia. And today is the satellite Landsat visit Malaysia. Last 14 days, that satellite is already coming to Malaysia. Okay, so there is times where the satellite come in. So normally times in GIS we call it temporal. It's not tempora, temporal. Tempora is Japanese food. Okay, next, what we have now? The introduction of GIS. GIS can be defined as a system of hardware. What is hardware? The computer. What is the computer? The motherboards. Next, the screens. Next, we call it the cabinet. Next is the PowerPoints. Next, the cablings. Whatever is called it hardware. So in GIS, we also have software. Okay. And in GIS, normally because we are dealing with graphical, the digital storage is very high. That's why we need storage. So now we call it the cloud, right? The storage on the web. So for GIS, we have our own storage systems in terms of hardware and software. One of the best you want to keep your data in digital, the storage is Oracle. I not recommend it, but normally GIS people, they aware. the Oracle's one of the best solution for the hardware and software in terms of storage in GIS industry, because GIS using a lot of space because it's dealing with the graphical. It's graphical, it's not text and number. Text and number, the storage or the hardware is very low. But GIS GPS, because we need something that analysis the data is verified and so on, we need hardware and software is very tip top at every time and must be ever ready. And GIS also have data. What mean data? So you normally you have data from satellite. You digitize map from Jabatan Ukur Pemetaan. You take, we call it the digital map from Jabatan Ukur Pemetaan. You bought it, maybe 50,000, and then you put it in your database to make sure that you can do a mapping. That is data. And then you buy it 10 years ago, a data from the photogrammetry from United States of America if they want to sell it. So that you must select the data based on your project. You don't buy we call it, you don't want or buy any data in your project or in your study, because what data you want, you buy and fit in your system. And organization structure for collecting, storing, manipulation, and spatially analyze data and display information resulting from the process. So we need organization structure, mean that who is the manager, who the assistant manager, who is the engineer to in charge with this, we call it geodesy survey, who is, we call it GIS teams who work with mapping, who we call it work with GPS, and then they integrate data at which departments. They have, we call it draftman, they have, we call it assistant engineer, they have data analysis, they have, we call it software engineer, they have, we call it hardware engineer, and so on, to make sure that this thing is really happen. And in Malaysia, we have a few company that's government set up, for example, MacGDI, Agency Remote Sensing Negara, and so on and so on. They have this structure. So the people who are responsible for collecting, storing, manipulating, and spatially analyze data and displaying information resulting from this process. What do you mean of collecting? Collecting that sometimes you have the maps, but your maps not representing the lampposts for the streets. So your team buy the satellite image. Because the lamppost is very small, you must go to the site using GPS to collect the coordinate. So when you collect the coordinates, and then you are storing the satellite image and all the GPS coordinate about the lamppost you are storing, then you are combining these two, we call it these two data, graphical data from satellite and GPS satellite in one maps, and then you put it a dot or donut or the donut shapes on your maps about the lamppost. We call it manipulating, and then you can see that how many lampposts in the KL street. So you are manipulation and spatially analyze. Where is we call, is it Putrajaya have more lampposts or in KL town? So you can compare, especially analyze data and display information resulting from the process. You show to your boss. Is it the lamppost is become the waste for the Kuala Lumpur city center, or the waste at Putrajaya, or we should take out some of the lampposts that normally is not give you anything. Okay, because last time maybe they overlook about the positioning of the lamppost, or maybe they're over positioning. Okay, there is the example about how you can do the collecting, storing, manipulations, and spatially analyze data, and is displaying information resulting from those processes. Displaying information, something like you print the hardware, and then you give to the, we call it the meeting in the files, in a hard one, you print in the, maybe in a A3 size, you show that the roads and then the lamppost, so everybody can see So that we call it displaying information. Okay. Okay, next. Okay, this one is collect, storage, and retrieve information based on its spatial location. So you collect your data, for example, that you bring up, we call it GPS, and then you doing the kinematics, and then by boats, you bring your GPS, you set it something like kinematic GPS survey. So you start your boats, and then you we call it take the boats maybe 3 hours, follow the river, and then you bring up with you, remember that GPS kinematic, so you can see the river shape. Maybe we call it the width of the river, and maybe sometime we can get, we call it the length of the river that you have traveled during 3 hours. This all information you collect, and then you store a GPS, and then you retrieve, put it in your computer, because this computer, when you retrieve after you collect and store, the times, loggings, X, Y, and Z, and then give you a date where this information you should, we call it integrate, or you can further up examining for the purposes. Identify location within a targeted environment which meets specific criteria. For example, that you are the environmental enforcement team. Okay. Then you go to the river. You can see that is the water is we call it is a very black, and we show that it's a very low water quality. But you don't know the source. What is the source? You don't know. Okay. So you bring in, maybe we call it your GPS and hell, your logs, we call it the data X, Y, and Z, and then you bring up to your office. Maybe your office have a maps, so you key in, we call it the coordinate. You can see, we call it your positions. Then you zoom in or you zoom out. You can see that which factory is very nearby to your sample you take. It's a very black one with the GPS data that you take. You already take it, right? You take it, and then you put it in the system. They will show you which factory is nearby with your locations, and you can check what type of the industry process. So if you're strong enough, so you can give them a notice, okay, and you send them a notice based on your GPS coordinate and the reading of the water quality during your sampling in the site visit. Okay, and through GPS also we can explore relationship among data sheet within that environment. For example, that I'm we call it doing management of slope. So you know what happened when we doing we call it when we doing drones. I take it from my students. We discuss about the drone data, about the Cameron Helen. We can see that they have similarity. The place where very prone to the slope failure, it showed that a very steep slope, and then that steep is a very high, more than 10 meters. There is always have slope failure. So we see this one because that map show the coordinates and give, we call it the type of slope, and also give, we call it something like what is the stiff degree of the slope, right? So we can make conclude that 10-meter steep slope normally in Cameron Helen give us a very danger place. Okay. Analyze the related data spatially as an aid to making decision about the environment. One of that I showed you. This one is maybe we call it. One example I give you is enough already. And maybe you go. We call it. Very easy. Sometimes you go. We call it not to river. You go. We call it affected one. For example, that's you go to the forest. You can see that a lot of the logging activity, and they cut the balak tree, or we call it the berlian tree. So you take GPS and then you go to the forest department, show them the coordinate, show them the photo, show them the GPS, the coordinate readings. So if we can help them to go and visit and monitor the sites to make sure that no people not really encroach the area and then destroy. We call it the green place. Last one is facilitate selecting and pass data to application specific analytical model capable of assessing the impact of alternative on the chosen environment. It's a very hard to give you example, but I will give you the example for like this. Okay, if you want, we call it housing development. Of course, you don't want that your housing is flooded, or we call it, you don't want to become floods, flash flood and so on. So don't select the piece of land that always flooding that area every year. Okay, and you can using GPS to visit the place, log the data, and then you go to the Google's search, we call it by coordinate. You can get to the point. You can see in front of that your land you want to develop, either is river, the back is maybe we call it a lakes, this side maybe a river. This one you can see that it's not really good, because you can create a lot of problem in future where the site that you want to build up, the housing schemes is always flooded. Okay. So use of GIS. Wow, GIS is a many things. One of that is now is navigation. To determine optimal location for roads, railroads, airport, utility, and etc. Optimal location. It's something like Waze. You have, we call it Google Map and so on. In UK, you have TomTom and so on. It can help both government and industry to efficiently manage their infrastructure such as water, gas, electric, telephone, and civil line. You see that water, gas, electricity, telephone, and civil line, normally they put it, in Malaysia, it's a very dangerous, they put it beside the road. So sometimes you want to repair, we call it, I have the problem last time when working with the contractor, where we are digging with water pipeline where the pipe is leaking. Then suddenly we call it our backhoe, or we call it our bulldozer, hit the electricity cables and shutting our backhoe. And according to my supervisor, this backhoe lift up 1 foot from ground, flying on from ground. It means that our electricity gives shots to our body of our backhoe. Backhoe means that that's excavation vehicles. Because we are not like in the Korea or going to America where they put it all the water, gas, electricity, telephone, civil line, and everything, internet, everything. They put it in one sewerage, in one tunnels. So this tunnel, they put it precast concrete, and it's very big. They manage it and they share with all the pipe, water pipe, gas pipe, electricity cables, telephones cable, and sewerage line. So because the Malaysia will still going to that process, so you must be careful that sometimes you must check with the agency before you are doing the excavation. Maybe if you want to, your pipe is leaking under GKR or under, we call it SADA, or maybe under PBA Pulau Pinang, you must go, we call it with Petronas, with TMB, with Telecom, or maybe with IWK. Make some advice from them. Maybe they have the position of GPS. Where is their location about their piping, or we call it the sewerage, or maybe about the infrastructure. So you take the coordinates, you must consider when you want to dig in, make sure that don't go to that coordinate they are give to you. Okay? Even though your water pipeline, because it's start during after we independence, is a very around 70 years before electrical come in for the whole Malaysia. So you must call all these agency to come and show to them that you want to dig in. What is their advice? Maybe they can have the standby, we call it team to help you. And then again, if they have GPS coordinate, you're using GPS to make sure that coordinate don't go and excavate, because it will give your company in deficit, because they will summon you, they will give you the court case if you destroying their property. All right. And GIS is used to make maps. I will show you that satellite, how they get maps, everything about maps, right? And then to establish the most efficient routes for emergency vehicle and school bus to locate fire hydrant, etc. Wow. So emergency vehicle like ambulance, they need, we call it like in United States of America, they have many lanes. So which lane they should take? For example, waste, they will give you, we call it, sometimes when we go, last time I had experience in Penang. So I say that I want to go from, I think from airport going back to UiTM. So he bring me, the road is very small, something like I never, we call it pass through before this, but it's no heavy traffic jam. So you can a little bit far, a little bit we call it you should take a corner and so on, but in terms of the time it's very best, because waste always give you a short time of period during traffic jam. Okay, and this is for example, and you look at this one, I think you must understand this one, and this is we call it about GIS. So GIS actually, we have a layer of map. For example, that's we have land use. So land use, we can take it from the municipal council. Where is the river? Where is the building? Where is the parking? Where is, we call it the park area? Where is the most, and so on. So they have this map. So normally we take it from local authority. We call it Malis Pembenaran Seberang Jaya, or maybe in Malis Pembenaran Seberang Jaya. And then maybe you have a local authority like DBKL, Malis Pembenaran Selayang, and so on and so on. And this is the elevation. Normally you take it from Jupum. Elevation means that's a contour. But you can see this one, the contour is in color, mean that this image in digital. This image is from satellite, digital. All right. And then it's a parcel. Parcel mean that, you know, the Grand Tanah, they have a lots, land lots. Okay, they have bearings, what you're doing. And then the ownership, this one you take from the Pejabat Tanah dan Galian. Okay, in Malaysia we call it Pejabat Tanah. And then you have streets. Okay, street normally is also from Jupum. The latest street in Malaysia. And maybe you have the customers. How you get the customer? Maybe you are doing on ground survey. You come up with one company, we call it from business. They want to know the customer. And you can see that the customer always come from the side of this one, building and residential. You can see the customer. Okay, so when you integrate this one, 1, 2, 3, 4, 5, you get this one, 3D. That is your final. Okay, this one is 2D. Or this one is 2D. Right, this one is a 3D. So they generate from 2D to 3D view. So now you understand. And more important, you can see 3D here. You can see the strata of soil. You can see there's a river. This one, the real one, real world. This one, all the data we take it from a different agency, and this process we call it overlay. So this process we call it overlay. Overlay. We overlay how many maps? 1, 2, 3, 4, 5. 5 maps. And we get this final. Alright, this is the concept about GIS. Okay, what is it? What is, we call it, what do you understand by this one? Ecological GIS. So, they want to do something like a project in the green area, and this is the result about the data. This is the area eco-type impacted 57. If you build at this area, and then percentage impacted minimum 1.45. They have calculation, impacted average, impacted maxima, impacted index, eco-type acres impacts, coastal primary acres impacted. This one, how much the forest should cut in? 41,000 acres is very big. And then upper forest acres, 31,000. So that is the impact if using this one. If you shift to this one, so the value over here is changing up or going down. Okay, there is one of the GIS can offer you where you want to build up a stadium, where you want to build up, we call it the housings, what is the impacts, impact to go into environments, impact to river, impact to community, fauna and flora, and so on and so on. Even though the temperature and the lands, the soil type mean that's how you contaminate the soil. Okay, for example, when you want to build up pusat pelupusan sampah, mean that you have the waste. So the waste normally you accumulates and then you burn out. You're doing a backfill and so on. They also can destroy the strata of the soil. What is the objective of GIS? Actually, the main is to reduce the time and money consuming activity of handling, recording, and researching the mountain of data. Mountain of data is not the mountain, mean that metadata. Metadata is a big data we have accumulated, generating relating to the land. And you must remember that time, maybe you have your father. Your father is maybe, we call the age around 51 like me, after 60 to going to 70 or so on. Last time they didn't have GPS. When they going for the Hari Raya, they want to search for their brother. Maybe 20 years, already 20 years they not meet up. So when they go, we call that place, we call it, sometimes they remember that place, sometimes they forget about it. So what they do, because don't have GPS, don't have any smartphone yet at that times. So they're asking people. Maybe they start from the mornings until 4 p.m. After 4 p.m., they found out the route. They found out the house of their saudara, of their brothers, of the sisters. And then after 2 hours, they should go back to the home. Just 2 hours meet up based on the searching from 8 to 4 p.m. 8 in the morning until 4 p.m. So they waste a lot of time. Because now we have GIS, put it in GPS, we say this navigations, we put it somewhere, we call it Waze, we call it Google Maps, we have TomTom and so on. Many software and many applications, it gives you a reduced time. Okay, a reduced time and give you a reduce of money, because when you are driving from 8 to 4 using your gasolines, so the gas is very expensive, now it's become cheaper, but still you waste the gasoline or the gas or the petroleum petrol in your car from one house to one house, go and ask. Okay, so you are, we call it not save the money. Okay, and then we have now GIS, we have GPS and so on. We can navigate, we can call, and then we can integrate with the traditional one. We ask the people. So maybe you start from 8, I think at 10 you already reach your brother or your sister or your father for Hari Raya celebration. To collect raw data and transform it by overlap by various analytical calculation into new information that can be help us to make decision. This is one example. This is one example. Okay. All right. What is the advantage of the GIS? I think remember is we call it make you easy for your life, save your money, save times. You also can make sure your family safe using the Grab, because the Grab have the software integrating GIS and GPS to make sure that you have the Grab software and many things. So we look at this one, advantage of GIS. To switch from hard copy maps to computerized, GIS has provided many benefits. So now last time we have hard copy. So many people last time the map is always used for the engineer, the map used for, we call it, the very high ranking people, government servants, and so the big contractor and so on. Nowadays, the kids who maybe 4 years, 5 years or 3 years, they can know how to use, we call it digital data, digital maps, using the Waze, using the Google Maps, maybe the send their locations. So now it's benefiting when we are computerized the map to become and convert to GIS. Store and easily update large amount of data. So last time, if we call it, we have the data in the hard copy, we need a very big buildings, we need icons, we need a big, we call it paper to print in, to sketch in, and then to copy it. And more dangerous if the store is, we call it under fire attacks. All right. Short and store spatial data into thematic layer. Data are stored in layers, so it can be analyzed separately. Okay, right. So you have this data, right? You have this data. You have this data, right? So if you have, we call it the data, last time in we call it in hard copy one, in a hard copy on the paper. So how we want to overlay this one? Unless every drawing must be on the transparency paper. But last time transparency paper is very very expensive. So how we call it? They want how they want, we call it to do this overlay process. But based on computer, you have digital data on paper. So you can see that you can integrate like this. For example, you can use the customer. You can use data customer and maybe with the land usage. You also can integrate streets and elevations to make it a second project. This one is first project. And maybe you can create customer, process and use to make it three, your objective or your three project. So now based on, we call it this data, we can integrate. Maybe we can integrate this data and this data and this data for number 4, project or objective. So you can see that when we change, we call it the maps to computerize. It can give you storage and easily update a large amount of data. Okay, so store mean that we can store and we can retrieve back, or retrieve mean that we can call back and use. Okay, easily update large amount of data mean that if this map, if this map, the straight map is using MRSO system. The parser one using the, maybe we call it GPS system, right? And this one may be using UTM projections. So we have 1, 2, 3 projection, but we want to overlay. When you want to overlay, you must use either UTM, either GPS, either MRSO. So last time it's very hard to change from UTM to GPS projection, GPS to MRSO, even though MRSO to the UTM. So based on now computer, they already calculate, they already have the template. You just choose either MRSO you want to change to the GPS coordinates, or you want to go into UTM. So it's very easy. Okay, there is what we call it, how we want easily update the large amount of data. Alright, there is number 1. Okay, right. So we are going to, we call it number 2, sort. Okay, sort and store spatial data into thematic layers. Data are stored in layers so it can be analyzed separately. Again, it refers to this project. I think is very, very good example, huh? All right. So again, this example. All right. Okay, now we finish for this one. Number 3, zoom into section of the display data to generate additional graphic. So like this one. So you have, we call it these graphicals. You can choose this one. You can change the parameter over here. You can add the parameter here. You can put everything. You can do the editing. It's very easy. Whatever come in, you must update easily, because this one a system that is a very, very convenient GIS system. One of GIS system is, we call it ArcGIS. ArcGIS. So this is, we call it GIS software. Right? So it can make like this. Okay, can make like this, and it also can overlay like this. And you can see this one is just one map. Actually, it's maybe overlay with 100 maps or 10 map or 20 map. But on display, you can see just this map. Actually, behind that, you overlay the data based on previous agency, based on the previous projection that you change become to one projection, and so on. So slide number 30, advantage of GIS. Analyze both entity and their characteristic data using sophisticated computer programs. Already we call it to you about GIS. Prepare map showing only selected thematic layer of interest. That you still remember that I show you around the possibility. We do the project 1, project 2, project 4 like this. How we overlay with this one, we overlay this one and this one, we can get one. We overlay this one and this one, so get objective 2. So that is, we call it prepare map showing only selected thematic layers of interest. So this GIS is rubbish in, rubbish out, mean that what you want. What is your project? So based on your project, we select the maps. We select the positions. We select the thematic maps. We select the objective. What we try to do. We not use all sometimes. Or sometimes we are doing a lot of analysis. We need more, maybe the 100 overlayers. And you must remember in Malaysia, the GIS data is very hard to get it because we are still develop our digital data in Malaysia. This is one of the concern about our research and our development. Nowadays, you can see that every department using maps. That is very good because most of the government servants, they send the staff to do the master. For example, I'm doing my master at University Putra Malaysia 203-205, doing a master in Geographical Information System, GIS and Remote Sensing. All right. So I meet up with many officers from government servant. Now they become boss, and that's why you can see that through your WhatsApp. Many maps they disturb. They will call it. They publish to make sure you understand. Okay, because the text people don't love. The people normally love in color and graphical and the beautiness of the infographic. Next, use of store data to prepare map at different scales. I already show you different scale. That is something like you have maps with another projections. Another projection, different projection give you also sometimes different scales. And different scale also sometimes contributes to your different projections. Okay, and normally the scale we use is different based on department, based on the heritage of department, based on warisan, based on their belief, and they also use, we call it different color codings. So when we buy, sometimes we must overhaul the data. Sometimes the data of JUPEM and with the data from local authority, we cannot match. So we must sometimes doing digitized bags. Sometimes we must we call it change the projections and then change the scales. And if your scale and we call it your projection is not same, you cannot do the overlay. And if you are doing with the wrong projection and with the wrong scale, it's not in the ones, what happened? Your data become haywire. That's why we call it rubbish in, rubbish out. So when you do analysis, maybe you can see the dengue populations. So maybe you can see that the people who actually very low infection by dengue based on KKM, in your map show high because you're not aware about the same projection and the same scales. Because the scale is 1 meter on ground is representative maybe 1 centimeter on paper or on computer. So you must remember that normally scale on map is smaller than the actual scale on ground, because if we put it scale 1 to, I mean that 1 meter on ground is 1 meter on paper in computer, is a very big data we must use. So to make it, we call it the data is we compress. So make sure that we use like this: 1 meter on ground representing 1 cm on computer or the hard copy. Okay, and remember when you're doing overlaying, you must have same scale, same projections. You must remember one operation is UTM, one operation is, we call it, another one MRSO, another one is a GPS and for BM satellite, the GPS. And then we have many projection. I will show you 3 popular in Malaysia. You must change to one projection and you must change to the one scale before you are doing overlaying. If you are not follow these 2 simple formula, your data become haywire. Okay. Import store data from different agency and this save the cost of collecting data. We already discussed the data from this one, this one. Different agency you put in your system and you save a lot of cost sometimes because the data is one. The JUPEM sell it to many people. So we save our time and money. They also save. We pay them with the minimum cost because they're government agency. And then create new maps by modeling or reinterpreting existing data. Yes, of course. This we have a data with a low cost and so on. We are modeling based on our interests. For example, that we call it environmental impacts when we do the development on the spatials. Okay. Right. So now what time is it? We already reached 11:22. A little bit more. We have part 2, hydrographic survey. We have the hydrographic survey. Wow, it's a very interesting. You still with me, class? Hello.
Yes, yeah.
It's very good. Can we go the hydrography survey, or you want to continue for tomorrow?
Tomorrow,
Okay,
tomorrow,
tomorrow.
sir.
If tomorrow is okay, we finish, we call it our class today. Okay, that is very good. Thank you, everybody. And very good. All right. So I can see that